Assalamu alaikum everyone. My name is Tahsin Farabi Rahman and I'm going to explain the definition of absorption.
Hello and good day everyone. I am from Group 1. My name is Song Shen Long and today I would like to present about tray tower concept design.
Hi, I'm Choi Ling. The part that I'm going to explain is calculation of tray tower.
My name is Ahmad Edafis bin Sharuddin and I'll be talking about tray tower application.
My name is Nur Sarabatisha and I will present on Pet Tower concept design.
Assalamualaikum and hi everyone. I'm Nur Adila and I'll be explaining on the pet tower calculation.
Hi, my name is Wan Muhammad Sharul Nizam bin Warostan and I'm gonna explain about the application of pack tower.
Hi, my name is Muhammad Aiman Iqmal bin Ahmad and I will be presenting on stripping. Come and join us.
Absorption. When two contacting phases are a gas and a liquid, the unit operation is called absorption. A solute A or several solutes are absorbed from the gas phase into the liquid phase in absorption. This process involves molecular and turbulent diffusion or mass transfer of solute A through a stagnant non-diffusing gas B into a stagnant liquid C. The examples of absorption are, for example, the exit ammonia water solution is distilled to recover relatively pure ammonia. Another example is in the hydrogenation of edible oils. In the food industry, hydrogen gas is bubbled into oil and absorbed. Desorption or stripping is the reverse of absorption, which is the removing of solute from a liquid by contacting it with gas. For example, the steam ripping of non-volatile oils, in which the steam contacts the oil and small amounts of volatile components of oil pass out.
Tray tower is a tower which contains a lot of plate column in it. Tray tower used in many chemical processes. One of the process is absorption process. And we need to consider the three main factors when we are designing a tray tower. So we know how the tray tower should look like since different process require different tray tower. For the concept design of tray tower, we know that tray tower exhibit larger pressure drop and also liquid hold up when we use high gas flow rate. This making poisonous and also flammable liquid is not suitable to be used in tray tower for the sake of the safety. Next, tray tower is suitable for falling liquid. Falling liquids will appear at the end of each process as a solid or precipitate. So all this solid or precipitate will end up on the surface of the plate, making it easy to be cleaned off. Last but not least, tray tower is also easy to maintain and also modified. Since each of the plate they are not stacked to one another, they have distance between them, so we can add and also remove the plates according to the process that we are doing.
The overall material balance on component A is presented by this equation. For a balance of A around the dashed line box, this equation can be used, where L prime is the rate of inert solvent water, V prime is rate of inert air, X is mole fraction of A in liquid, and Y is mole fraction of A in gas. The terms L prime, V prime, X naught, and Y1 are constants. Thus, the unknown values can be found using this equation. So, what are the steps that we can follow to find the number of theoretical trays? First, we can use graphical method. The first step is calculate unknown values using the first formula. Next, plot two endpoints of operating line, x0, y1, and xn, yn plus 1. Next, find two intermediate points to complete plotting of operating line. These points can be found using operating line equation, which is the second formula from the previous slide. After that, plot equilibrium line. Lastly, the number of theoretical trays can be determined by simply stepping off the number of trays.
There are certain kind of condition in absorption that require tray tower to be used instead of packet tower. For example, high pressure distillation. Tray tower can be used in high pressure, meanwhile packet tower can operate smoothly at low pressure, which might cause separation efficiency for packet tower to drastically decrease in high pressure condition. Apart from that, absorption that include corrosive gas or liquid also can use tray towel because tray towel has higher thickness material compared to packet towel. There are a lot of advantages using tray towel over packet towel. One of it is better in handling fouling sources. This is due to the fact that when the liquid causes fouling, even though the tray is blocked up, it is easier to clean it. Plus, tray towel provides better predictability compared to packet towel. Therefore, the plate efficiency can be predicted more accurately. However, tray towel also has its own disadvantages. One of it is the cost of plate column. Since tray towel were used for corrosive liquid or gas, then the cost to renew the plate column is too high because the material used is high corrosion resistant. Other than that, foaming can reduce the performance of plate column. Foaming happens when the overhead disengaging space is not high enough.
Moving on to PET tower concept design. PET towers are used as contacting equipment for gas liquid and liquid-liquid systems. Figure 1 shows a cross-section of a typical PET tower, while on the other hand, Figure 2 illustrates a typical PET tower with internals for improved distillation. The basic unit consists of shell, packing one or more sections, packing supports, liquid distributors, intermediate supports and redistributors, and lastly, gas and liquid entrance and exit nozzles. Many of the mechanical aspects of tower construction and assembly have an influence on the design and interpretation of tower performance. Every effort should be made to increase the effectiveness of contact between the process streams and to reduce losses by entrainment or wall effects whilst minimizing pressure drop. At the same time, the design must be consistent with the economies detected by the process and type of construction. The shell is usually cylindrical, although square wooden, light metal or reinforced plastic towers are used. For PET tower, the distributor and packing define the performance of this equipment. Their proper selections entails an understanding of packing operational characteristics and the effect on performance of the points of significant physical difference between the various types. Good progress has been made in the past decade in the development of packing for difficult and wide-ranging process applications. These types include random particle packings, structural packings, and grid packings.
Moving on to the pack tower calculation, this is the diagram material balance for a counter-current pack absorption tower. The overall material balance on component A equation is shown below, where L prime is rate of inert liquid, V prime is rate of inert gas, Y1 is the mole fraction A in gas, and X1 is the mole fraction A in liquid. The flows L prime and V prime is constant throughout the tower, and A balance around the dashed line box here give the operating line equation. Then steps of calculation. Firstly, plot an operating line by referring to the previous equation and equilibrium line by referring to the appendix. By using the trial and error, determine yi, xi, or x star, y star. For the first trial at first point, calculate the slope by using the given formula. Then, by plotting the slope here, it will give the values of yi1, xi1, and y star 1. At the second trial at first point, calculate 1 minus xim, 1 minus yim, and the new slope. If the latest slope and former slope is approximate close, then the yi1, xi1, and y star 1 values are accurate enough. Then, calculate slopes at the second point. By plotting the slope at second point, it will give the values of yi2, xi2, and y star 2. The last step is calculate the height of tower, which is z based on the given film coefficient k prime y or overall coefficient capital K prime y by using the below equation. Then, it will give the values of z.
Okay, for the application of pack tower is commonly used in the process of separating, filtering, vacuum distillation and purifying that is applied in the industrial sectors such as pharmaceutical, petrochemical plant and oil and gas. Okay, what's more, pack tower is also used in air pollution control technology where the sole purpose is to convert polluted air into clean filtered air. This process includes the removal of air pollutant by initial or diffusional impaction. The advantage of using pack tower is that the equipment cost is relatively low despite having large production capacity. Besides, the pack tower undergoes continuous reaction at low pressure drop where we can constantly obtain optimum absorption as long as the tower maintenance is well kept. Pack tower also capable of handling foamy fluid and the tower itself is structurally ready to be re-equipped with additional makeup. However, the disadvantages is that it cannot handle wide range vapor or liquid rate per unit cross-section due to its inflexibility for handling wide range gallon per liter ratios. Pack tower also susceptible to gas liquid maldistribution, especially during packing, resulting in the poor mass transfer. Moreover, it cannot handle the dirty fluid as it tends to deposit, thus reducing the performance.
Last but not least, I would like to teach you on what is stripping. What is stripping actually? Stripping columns are used to remove unwanted materials from process steams. The diagram here shows an example of a stripping column. There are many types of stripping columns used in chemical engineering industry, but the most commonly used is a stripping column and steam stripping column. A stripping column has two different types, which are pack column S strippers and sieve tray S strippers. The diagram here shows the pack column S strippers and sieve tray S strippers. Pack column S strippers has its own pros and cons. It is the most cost-effective overall and can operate at wide range of airflow rates. However, fouling can occur very quickly and backpacking must be removed and washed or cleansed with acid. On the other hand, sieve tray strippers also has its own advantages and disadvantages. It is easy to prevent fouling, and additional sieve trays may be added if greater treatment is desired. Unfortunately, fouling at some point is inevitable. A narrow range of airflow rates can be used to prevent volatilization without interrupting the water flow. That is all from us. Thank you very much. Don't forget to like, comment, and subscribe.